Good morning, good afternoon, and good evening, everybody. Welcome to our today's webinar. My name is Filip Cerny. I'm the product marketing manager at Progress. And with here we have a Microsoft professional specialist, Nicolas Blank from the NBC Consult Group. Hello, Nick.
Hello, Philip. Lovely to be with you today.
Same here, same here. Thank you. So before we get into today's webinars, which is applying zero trust to data center networks, let me go over some housekeeping rules with you. So on your navigation panel on the right side, you have the first icon in the shape of the question mark. This is where you can leave all your questions throughout the webinar. We will try to answer as many as we can, either throughout the webinars or we have dedicated time at the end of the webinar to go through the questions live. Those questions we won't have time to answer, we will take offline and we will send you the answers later on. This webinar will be recorded. You will receive the recording in the follow-up email as well as the presentation. So with that, let me get into our today's agenda. So in today's webinars, we will first go to what is zero trust and what problems does it solve. We will look at some basic zero trust principles and then how zero trust is for Microsoft customers and what it's like to start with zero trust framework. And then we look at how zero trust complements networking. And then we will move to Flowmon solution and network visibility and security, which Flowmon provides. So with that, Nick, let me give you the word and the floor is yours.
Thank you so much. What was really important for me is that we get to have a very real discussion today on zero trust and security. And zero trust is one of these buzzword things that we talk about. And it's actually an insanely practical framework. And so let's get away from security marketing and let's talk brass tacks just for a little bit in terms of what is zero trust and why do we even care? And so we go back a little while to the a kind of simpler time in the early 2000s when we had data centers and firewalls and we thought we were secure. And we realized that security has always been a very hard problem, but we didn't really have this language thing for it because in the data center model and in the firewall model, we had this way of doing security, which was based on the fact that I will trust first, but verify afterwards. But actually, practically, that's very difficult to do because how do you verify after the fact? And a Forrester analyst called John Kindervag looked at this and created the terminology zero trust, which is much more along the lines of we never trust. We never trust anything. We always verify everything. And we treat the inside of our network very much like we do the outside. So consider that from a trust level point of view, that means that your inside network, remember that zero trust was originally a networking thing. So your inside network effectively is the same as the internet. We trust nothing on it. Now, zero trust is a set of security principles. It's very important to note that zero trust here is not a framework, it's not a product, it's not a service, and buying one product will never make you zero trust compliant because zero trust is a set of principles. So these principles allow us to address risk. And we have this common language of risk that we can speak to the business with because often our business leaders understand risk. They don't need to understand cybersecurity. And it allows us to address insider risk as well as external risk. So if we realize that we can't be zero trust compliant, that means in terms of our thinking, in terms of absolutely everything we do, we are able to implement not only security, but we implement IT, we implement HR and finance even to zero trust principles. Next. So principles are very simply, we verify explicitly, we use least privileged access, and we assume breach. But let's just unpack what that means for a second. So if I verify explicitly, and I verify everything explicitly, I will take the fact that Filip has introduced himself and said, that's great, but I don't trust your introduction. So can you please prove that Filip is Filip using something else, like an ID or a credit card, depends on who I trust more, right? But I need a second factor. So Filip isn't Filip unless Filip can prove that he's Filip, and he'll have to do that on an ongoing manner. So I never trust that Filip is actually Filip. Then, wouldn't it be nice if Filip could only do the things that his job role actually entailed and nothing else? And that is how we wrap up least privileged access. Now, I alluded to things like finance. That also means that Filip actually can't, if he's a payment clerk, for example, make any payments without a second factor, like some second form of authorization. From a IT point of view, that means that we no longer have domain admins. When I joined companies beforehand and I was a system administrator, the very first thing I'd ask for is domain admins, because otherwise I can't do my job, right? And we need super user, we need global admins to do our jobs, but actually we don't. And what we do from a zero trust point of view is we take all of those privileges away and we only grant what is absolutely needed when it's needed. Now, the last one is a little bit contentious because it makes all the chickens nervous. Now, assume breach means that I live in this constant attitude of I am expecting that I have an attacker on the inside or the outside of my network, and I need to do something about it on an ongoing manner. So we get away from this previous 2010 model of I've bought a firewall, so therefore I am secure, but you're not secure. And it was difficult to explain that to business people because we spend all this money, but what do you mean I'm not secure? And so from a zero trust principle point of view, when we assume breach, we behave accordingly, and it radically changes how we do IT, finance, security, absolutely everything. Now, from a how do we apply this point of view, or what do we apply it to, you can see the beginnings of what we have on the bottom if we're talking about this from an IT point of view. So that includes identities, endpoints, data. That can be surprising that I say we can have a zero trust view on data, but I'll talk about that in a second, including applications, all of our infrastructure and networking, considering that zero trust started as a network-based set of principles. We've expanded that from networking all the way back to identity, with identity being known as the primary perimeter these days, no longer firewalls. Next, please. So if you are a Microsoft customer, you think, that sounds great, Nick, but where do I start? I'm glad you asked. So I've started you off with a URL. And Microsoft has written extensively about zero trust, so extensively that there's actually a lot to read about. And this is one of those things of, good gosh, Nick, where do I start? And where do I go? And what do I do first? And there's actually a fair amount of things to digest. So in all of this, you can see that on the left, we've got adoption frameworks and we've got implementation guidance in the middle. And all of this relates to the same three principles. So those three principles are verify explicitly, use least privilege access, and assume breach. So let's go back to that first thing that I spoke about with identity, for example. If I verify explicitly on identities or endpoints, which are actually both different kinds of identities, because we have human identities and machine identities, we always authenticate and authorize doing that on all available data points. So to put that practically, let's assume Filip says he's Filip. Okay, that's nice. And where is Filip in the world at that point in time? Well, he is in North Korea, he's in Russia, he's in England and America at the same time on 4 different logins. That doesn't sound right. In the old data center world, that would be very difficult to try and figure out where's Filip logging in from. in a cloud world, we would say that Filip needs to be authorized based on the primary location that he works from, who he is and who he proves himself to be from a second factor point of view, maybe the business hours that Filip works, which is another point of authentication and authorization. And then we decide what Filip can have access to. So without reading the slide to you, you can see how we think about these three principles from Microsoft point of view, and then looking at assume breach being critical for us. When we assume breach, we want to be able to respond to breach, and that also means that we look for breach all the time. That means 24/7, 365, we looking at how could I be breached from a threat hunting point of view, but also we look at our threat detection and our defenses from that very same lens. Next, please. So let's be a little bit more practical about how do we get started. Now, this is the same documentation URL that we saw earlier, but I've just unpacked it a little bit. I've taken a view from the middle. And if we click on the left, you can see that Microsoft has provided us with an adoption framework. Now, this adoption framework, that might sound relatively similar if you've ever done anything with the Microsoft Cloud Adoption Framework, which is how do I go to cloud in a meaningful, scalable, and repeatable manner. So this zero trust adoption framework has been written along the same principles. And this overview starts with how do you explain security and zero trust to a business audience. So in this article, and you can see that on the right-hand side, and I'm able to scroll through this because obviously it's a screenshot, but you can see that we are able to unpack zero trust for the C-suite. So literally the CEO, the CFO, the COO, not just the CISO. And we're able to make zero trust real, again, in the language of risk, for the people who need to pay for the bills, previously never having understood what are they even paying for. And to make this even more real, you can see that on the left-hand side, we've got two business scenarios. So we've got secure, remote, and hybrid work, and we've got identify and protect sensitive data. And you might just say there's a lot more scenarios to that, and you're absolutely right. And what we have been doing as NB Consult is that we have been writing this with Microsoft, and there's a lot more scenarios coming. So we are rather qualified to speak about how do we get started with zero trust because we've been wrestling with this about how to make this meaningful for the last year. And I'm delighted to announce that as of last week, Monday, all of this is live and available to the public. And over the next few weeks, you see more business scenarios added to this. Next, please. Oh, that looks like a scary slide, doesn't it? But where do we start? And let's start from the left-hand side. We start with identities and endpoints. Now, why do we start there? Well, I've got a very interesting number that says that anywhere between 92 and 96% of cybersecurity attacks can be thwarted with basic hygiene. Now, basic hygiene for me means, for example, that identities are MFA'd, non-negotiable. It doesn't matter how important you are in the business. You must have MFA. There's no exclusions. And a very recent case study was, or actually a very recent attack from a company with 110,000 users, and they were running Microsoft Defender for everything, and they found the attack and they mitigated the attack. And the question was asked, well, how did these attackers come in? It was found that out of 110,000 identities, 11 didn't have MFA. So if we consider that MFA becomes non-negotiable, we automatically raise that bar up into the high 90s. Then if we look at endpoint protection isn't just making sure that you've got patches deployed. Very, very important that your endpoint is patched. It also means that you've rolled out threat protection to absolutely everything. And here we're looking at threat protection that is able to look at everything that happens on that endpoint, not only in terms of antivirus patterns, but also how does that endpoint behave? And is it behaving in a manner that's appropriate for what it is? So a workstation, for example, shouldn't be port scanning infrastructure around it in an ongoing manner because it sounds like a threat moving across my infrastructure. So then moving into the middle, once we've done the basics, so we've done the basics in terms of identity, and we've done the basic in terms of endpoint. Endpoint, just to repeat that, is I'm patching all the time and I've got next generation antivirus of some sort on there. Then we roll out threat protection across absolutely everything. So in the Microsoft landscape, that's very simple. That's Defender for everything. Microsoft has a Defender product for your vending machine, for your water cooler, for identities, for servers, for databases. So you roll out a threat protection and you roll out a solution that is able to take advantage of continuous threat assessment across your entire landscape. So you're running hopefully one tool and not 30 different tools. And you also, at the same time, because you've bought yourself some slack with doing the stuff on the left-hand side, now that you're in the middle, you roll out policies and you're able to actually author the policies that take you from who did what and when type of thinking after the fact to proactively defining who can do what to and when can they do that. So Filip, as an administrator, can only administrate when the permission is given to him at a point in time, and then it's automatically revoked. So let's look at all of those assets on the right-hand side. So we've got the basic hygiene. Now we've got threat protection rolled out across our real estate, but now we need to start thinking about, well, infrastructure on the bottom right-hand side. I can roll out threat protection to servers, containers, my infrastructure as a service, my databases, so that makes sense. My data is harder to do. And data, for example, if I want to classify and protect my data for the kind of data that it is, so HR data is respected as HR data, that means I need to classify and categorize my data, which I can do when I have the luxury of time to do so. If the stuff on the left, identities and endpoints, is eating all of my time, then the stuff on the right-hand side becomes very, very difficult. However, one of the mainstays for us in terms of Zero Trust, remembering where it started, is network guidance. So if I consider that I've got a private network and a public network, and we mesh those two things together in terms of a security landscape, let's look at what Microsoft tells us to do from a Zero Trust point of view. If we look at Zero Trust networking. So next slide, please. So we actually have a fair bit of guidance, and it aligns with absolutely everything that we've spoken about. You can see that we've got basic and advanced threat protection because why? Well, we care about assuming breach, and we care about ensuring that you can only do what you're supposed to be able to do at that point in time. So that talks to network segmentation, it talks to encryption. So we are relatively secure. Now, there's a good thing and a bad thing about this guidance. The good thing that the guidance is actually relatively thorough. Very long article. There's a lot to do, and Microsoft gives us a lot of guidance in terms of what to switch on and when, except it's only for Azure. So if you click next, you'll notice that the products covered in this guide is for Azure everything. So that assumes that you're cloud deployed, and it assumes that your critical workloads are in cloud. However, from a data center point of view, having learned everything that we've just learned and living in a world of assuming breach, where do we go? And with that pregnant pause, I'm going to hand over to Filip to tell us, how do we solve a zero trust problem in a modern way in the data center?
Super. Great overview, Nick. Thank you very much. So, Nick has been saying, and it's known in the IT world that a frequently used phrase that describes zero trust is never trust, always verify. But how can you verify all of your users, devices, and the systems are following the framework? How do you know whether one of these devices is compromised? And well, one of the answers can be is the network or the network detection and response solutions, which can accelerate the adoption and effective zero trust framework by enhancing the IT teams with visibility they need to get going. They can continuously monitor and safeguard the network traffic, validate policy enforcement, and support enhanced collaboration between traditional siloed teams. So before I deep dive into the Flowmon's network detection and response solution, I just want to reiterate why it is important. So if you look at the cybersecurity threats, let's say in numbers or in some statistics, we can see that the global cyber attacks have gone up by staggering 81% since 2020, since the onset of the pandemic. And what's even more is that cyber attacks occur more frequently than most people think or indeed see, with average ransomware attack occurring every 11 seconds, often with consequences of threat to release the data. And that, of course, can now damage the companies even more than just paying the ransom. Majority of the times, I think over 70%, the threat is with the ransomware attacks, there is always a threat to release the data to the public, with the average payment of around $800,000. And I think the last statistics I've seen, this number is even going up. And if we count the other costs, meaning the business isn't operational, the loss of reputations, and all these things, the average cost of overall ransomware attacks can be in number of millions, or in this case, $40 million to date. So once a bad actor is in your network without any visibility tooling, such as Flowmon, it will take on average of 206 days to identify a breach. Couple that with an average of 23 days of downtime, it truly is a recipe for a disaster. So just the detection time alone is enough to make any IT admin nervous about the prospect of trying to find what is lurking in the network. And finally, for now, at least by the year 2025, cybercriminality is set to reach the heights of $10.5 trillion annually. Just to put this number in perspective, this is, I think, the overall size of economy of whole Europe is at $16 trillion right now. So let's say 2/3 of the cost of world cyber attacks globally is basically 2/3 of European GDP. So it's just staggering numbers. So let's look at what we can do. So to lean on Gartner and its security or SOC visibility triad, Gartner suggested in 2015 that this triad aims to prevent cyber attackers from remaining in your network long enough to achieve their malicious goals. So traditionally, enterprises relied on security information and event management tools like CM to detect and stop cyber attacks. However, a lot of manual analysis was needed to interpret and the collected data in CM until the endpoint detection and response, the EDR, and network detection and response, NDR solutions were introduced. So EDR and NDR both specialize in different use cases. While endpoint detection and response relies on a piece of software or an agent to be installed on the monitored endpoint to inspect the activities in details, network detection and response monitors all aspects of the network communications from, let's say, bird's eye view of the IT activities independent, well, it's independent whether or not the agent is installed. And Gartner suggests that the main reason for creating this new visibility concept is because the escalating sophistication of threats requires organizations to use multiple data sources for threat detection and response. And network-based technologies enable technical professionals to obtain quick threat visibility across an entire environment without using agents. And since its introduction in 2015, Gartner, as well as many other IT professionals, can confirm that organizations leveraging the triad methodology are seeing a significant decrease in detection time. So let's look a little bit closer why network is important. So when we talk to our customers, we usually see that still majority of the security budget is being spent on prevention, which means perimeter and endpoint. But the people often leave out the network because, and if we think like an attacker for a second, attacker always assumes that you have some sort of perimeter protection like firewall in place, as well as some endpoint protection. So they do constantly update the malicious code to stay undetected. But they have to leave some footprints, some breadcrumbs behind in the network, because network is the single source of truth for all the communications. The monitoring the network traffic can provide the real-time threat detection. We can even analyze the encrypted traffic, provide incident response, and overall it improves the collaboration between IT teams, specifically network operations and security operations. So if you look a little bit closer at the Flowmon solution can be divided, let's say, into three main categories. So the core one, which we are talking about today, is the network detection and response capabilities, essentially being able to collect and analyze the network traffic and look for early early indicators of compromise, some basically ransomware attacks, malwares, and stuff like that. But because we have this visibility into the network traffic, it also provides a lot of value for network operations team, just giving them that visibility over entire estate. So it doesn't matter if your network is decentralized, you have locations, you have network in a number of different locations, London, Berlin, you have your infrastructure in the cloud or in the private cloud, public or hybrid. Having that visibility from a centralized dashboard is really essential and key value for network operations. And with that insight, we can even monitor the performance of web-based applications. So if I move forward to how the network detection and response solutions from Flowmon works, well, first we need to input the data. The whole Flowmon solution is based on collection of NetFlow IP fixed data. So we rely fully on network telemetry, but we can also digest full packets, reputation feeds, or IDS signature. Once we have those data, then we apply a number of different algorithms like machine learning, adaptive baselining, heuristics, reputation data signatures to provide the result, which is the events, the relevant telemetry for forensic analysis, captured PCAP files, alerts, CVE references, and basically have an overview of the incident that occur in the network. So moving forward to look at the whole architecture. Um, as I mentioned, if you look at this picture and we take it from the top, so we can have, that's the source of the data. So we can utilize the cloud native flow logs from AWS, Microsoft Azure, or Google Cloud. We can leverage your existing infrastructure like routers or switches if they have that capability to export the data, the IPFix NetFlow data. We can even leverage the products in our current portfolio, which is a LoadMaster. It's a load balancer, which has the capability to export the IPFix data as well. And when none of these options is available, we can deploy our own sensor, which is a Flowmon probe. It's just a passive device connected to network through mirror port or using taps. And we take the full packets and generate the IP fix. And there is an added value because we can enrich the net flow data, the network telemetry, with application layer information, which provides even deep visibility for more effective troubleshooting. If we moved in the middle of this picture, we can see that once we've got the source of the data, we can send it to a storage unit, which is an appliance called Flowmon collector. It can be hardware or virtual. And there we store and analyze the data. So from the basic point of view, once you send the data, you can see the full communications, who is talking to who, how long, using which protocol, and you've got this data stored. You can store it for a number of weeks, months. It depends on the storage of your collector. I think the largest Flowmon collector we have has 192 terabytes of data. So basically, you could say that we can keep the history as long as you would need it. And if we would want to display the data from different point of view, like from security or applications, we just run software extending modules on the correct collector. So having the network detection response capabilities, that's the product called Flowmon Anomaly Detection System, which we can just install on the collector, and immediately you will have the machine learning based threat detection. We can even trigger a full packet capture, and there is the added value where Flowmon collector has a memory buffer. So when an ADS, when we detect some sort of anomaly, we can trigger an on-demand packet capture, let's say for the next 10 minutes to generate a pcap file. And because of this inbuilt memory buffer, we actually can collect the packets that you need that are relevant when the anomaly occurred in the network. And the last module I mentioned is for monitoring the performance of web-based applications. So if we look a little bit deeper at the Flowmon intelligence, what sets us apart? How can we detect all these threats? Well, we use a combinations of different approaches. So as you can see on the left, we use machine learning, adaptive baselining, heuristics, behavior patterns, and threat intelligence. So for example, with machine learning, we continuously compute and analyze entropy between individual communication parties in the network to distinguish what's human-like and what's machine-like behavior. Typically, you could say that, for example, if an attacker would be trying to launch a slow brute password spraying attack, this is an example that can be detected by a machine learning detection. If you look at adaptive baselining, it's not the baselining in terms of statistical analysis of the whole data, but it's baselining of individual hosts in the network and how they behave, and comparing those behavior of those individual hosts to one another. So for example, you can detect that one host is generating much more emails than others in the same network, or much more DNS queries that others in the network, that others don't in the same network. This may indicate some sort of compromise that we can alert on. With heuristics, we work with probability. So for example, in peer-to-peer traffic, you look for multiple different symptoms, and you can calculate that there is an 80% probability that a specific device is probably plugged to some BitTorrent and using BitTorrent to download some media files. So we have all of these approaches, and we compiled them into more than 200 different individual algorithms, and we basically compressed it into now more than 40 different detection methods. And with those detection methods, we can provide that threat and anomaly alerts and event evidence for security operations, which can give them the value of early threat detection, definitely threat hunting capabilities to be able to hunt for the threats when they are occurring and quickly launch the incident response. But also thanks to the long-term data collections, we can also store these data or later on for forensic analysis to be able to build more resilient cybersecurity infrastructure. And For network operations teams, there is also a value that you can monitor your entire IT estates, hybrid, cloud, public, whatever. And you can monitor encrypted traffic and analyze any root cause of any network related issues quickly, because you have those eyes into the network, you see what's happening, as well as monitor the network performance. So just to highlight here, this is actually a great value when we talk to our customers, because you are bringing network operations and security operations teams together using one solution. So we see that typically those teams are siloed, they use different tooling, and whenever there is a problem, usually in reality, we can see we encounter this sort of finger pointing or blaming game, where you need to first prove it's the other team's responsibility to deal with the issue. So with Flowmon, you're taking all of these silos away. So what sort of anomalies, or what's the value for security operations that Flowmon can help them detect? If you take it from the right, it can be internal security issues like viruses, malwares, ransomwares, or crypto minings. It can be a change in the long-term behavior of a user. For example, we've had a customer who suddenly was trying to upload a large amount of data to Yahoo Drive, and which initially from the networking point of view didn't seem like a huge security risk. But when we looked closer, we see that the employee was in the termination notice and was trying to take the company's data for his own. So later on, when we look a little bit deeper, this could present a quite serious security breach. Attacks like port scanning, dictionary attacks, or traffic anomalies, where basically there can be a man in the middle attack. Someone in the network will be broadcast everyone that he's the gateway into the internet, gaining access to sensitive informations like logins and passwords. It can be operational problems like delays in or unresponsive services, as well as enforcement of company policies, like making sure that no one will be using BitTorrent in corporate network. So once we have all of these, let's say, threat events, we can integrate with a CM solution, and that includes Microsoft Sentinel as well. So we can actually feed only the relevant events, not all the traffic, but only those security incidents to CM. And we actually had a customer that because he was able to utilize Flowmon and just only send the relevant security incidents to CM from Flowmon, he was actually able to save quite a lot of money for the licensing of CM, because CM is licensed usually through the amount of data you send through. So by not sending all the data, but only the relevant ones that you want in CM, in this example, the money saved on licensing actually paid for the whole Flowmon solution. So to highlight the benefits, Flowmon Network Detection and Response provides automatic threat detections and threats hidden in the network traffic. You can leverage a context-rich anomaly investigations, and the great power of not relying on signature-based detections, but leveraging machine learning-powered engine is something that complements your security solutions that you have already deployed, like firewall and endpoint detection and response. So if we look at a little bit closer how a ransomware attack is carried out, if you look at it through the framework of MITRE attack tactics and techniques, we can see that attacker needs to first do some sort of reconnaissance, gain initial access. Once they are in the corporate network, they need to discover where are possible targets, how they can gain access and move laterally through the network, find out some sensitive information, collect them, and exfiltrate it from the network before they can do the final stage, which is impact and encrypt the data on your file. But each of these activity represents an unusual behavior in the network or a network anomaly that a Flowmon solution can detect and allow you to respond to. So if we look at the print screen from the Flowmon's user interface, we have actually simulated this ransomware attack. So we can visualize the data by priority. We can, so you know what to respond to first. We can filter the anomalies just purely based on attacker's activity. So, and how it correlates to MITRE attack tactics and technique. So you can see, for example, the event started at 9 o'clock. First attacker did some sort of TCP scanning, which corresponds to discovery tactic and network service discovery technique to MITRE ATT&CK framework. We can see that the source was this IP address in the local network. We can have the detail, and we can see that they were scanning for possible targets, which were these 3 IP addresses, and so on and so on. We can see this stage by stage. So in this example, we have actually replayed this scenario based on a real example. And as you can see on the timestamp, we started at 9 o'clock and finished in 25 minutes. But in reality, this attacker's activity takes much longer than that. They try to move slowly through the network so they get unnoticed and they can achieve their malicious activity. So we can also, with Flowmon, we can visualize the data just through the number of different dashboards and reports, or you can analyze it for more more insight. So the overall benefits of network detection and response solutions to IT operators team or NetOps and SecOps is to give them the full visibility so they know what's happening. That allows the early threat detection, forensic analysis, and incident response, because how can you secure and protect something that you don't see? Well, you can't. So overall, with the amount of visibility and automatic threat detection, we bring back the control to the IP operators so they can own the network. And since I've talked about a network quite a lot, but the zero trust in your data center with Flowmon is that we can apply those zero trust principles, which is verify explicitly, use least privilege access, and assume breach. And with Flowmon, we can help you with the verification, and with when you always assume breach, that means that you're constantly looking for threats in your data center, in your network, in your whole environment. And Flowmon is exactly that's doing that. We're continuously looking for threats and automatically alerts you when we find something and provide a single source of visibility for you to know what's going on. So that's been my part about Flowmon and how it corresponds to zero trust principles. Now there is a time for your question. So I see we have one question. Can you provide this overview in a better resolution? Cannot be read properly. So I hope this was an one-time instance and everyone else could see the presentation just fine. But you will receive the presentation in the, better quality for sure. So you will have those slides available to you. And I can see another question. How does Flowmon compare to Microsoft Defender solution? Nick, can you talk to that?
Yeah, it's a great question, actually. So Microsoft Defender, I said earlier that there's a Microsoft Defender for everything. And we have Microsoft Defender for servers, as an example, but we don't have Microsoft Defender for switches and routers. So if we consider how we do manage detection and response, we need to have a layer of visibility in our data center network. So Microsoft Defender doesn't actually speak to that today. And I'm not aware of any roadmap items where Microsoft is investing with being able to track threats and mitigate threats like they can on service containers, etc., endpoints, identities, cloud apps, and the list goes on. So from that point on, it's actually really, or with that point being borne in mind, it's really important that we have something that creates visibility in the network, because we can't manage something that we can't measure. And we also need to be able to instrument threats on the network. So from a pure data center networking point of view, we currently don't have something from Microsoft in the Defender suite of products that speaks to this.
Super, thank you. So this is exactly when Flowmon can help you. Okay, and looks like we just hit our time limit and there aren't any other questions. So with that, I see we've popped up another question, so okay, that's great. Some comparison with Asset, Sophos, and Bitdefender solution.
I'm happy to take that one.
Okay, go for it.
So there's two views to this, and today is not a product pitch at all. Today is very much about how do we address security, and what are we achieving with Defender. So if I look at what Bitdefender can do, so I'm going to pick on ESET and Bitdefender, very robust solutions in their own right from an antivirus point of view. Now, Gartner a little while ago introduced this concept of XDR, which is extended detection and response. So extended detection response means that you've got products that talk to each other, normally some kind of a software as a service type backend. So you have these products that talk to each other, and they perform event correlation amongst them. So if I say, for example, and we have this thing, the previous worldview of, I need best of breed. I can't have all of the products from one vendor. So that means I'm going to have a firewall from Cisco, or endpoint management from someone else, and someone else for servers, and someone else. And eventually I've got these 13 points of management. So when an event comes in, and I might have something that happens in cloud, something happens in identity, then it goes to a server breach. How do I put all of that together? And the answer is manually. So what Gartner defined and what vendors like Microsoft have been doing is, Defender is not just antivirus. And I realize that ESET and Sophos do a lot more than just antivirus. But in terms of being a Microsoft customer with a cloud identity, Defender brings all of that together as part of a solution that talk to each other. So it's a really, really good question. So ESET, Sophos, Bitdefender is what I would call traditional antivirus, with some of them going to what we call next-gen antivirus. And Microsoft gives you two flavors of that as well. And they have a traditional antivirus with Microsoft Defender, and they also have a next generation endpoint management solution that, as I said earlier, looks at what the endpoint does, not just scans antivirus. So looks at behavior and not just antivirus patterns.
Excellent. Thank you very much, Nick. Looks like there aren't any other questions coming. And with that, we hit our time. So thank you very much for listening in. Thank you, Nick, for a great presentation. And I look forward to see you on the next one.
Yeah.
Thank you, everybody. Bye.
Bye-bye now.